Hello everyone and welcome to this CU Boulder Flight Operations Supplemental video. This is a additional multi-rotor maneuvers video in which we use an RC flight simulator to better model and show stick inputs to UAS movements for the multi-rotor check ride. This PowerPoint will briefly cover ACS standards for each maneuver, but really focus more on showing what controller inputs are required to complete certain maneuvers. The following maneuvers will be covered in this video. Before we will begin, we will show you what each stick input does to the multi-rotor. Moving on to the first simulation, we can show that moving the left stick upward and downward increases and decreases the thrust and therefore makes the UAS move up and down. The next thing we can show you is that moving the right stick left and right changes roll and makes the aircraft translate right and left throughout the sky. Moving the stick forward and back, the right stick forward and back changes pitch. As you can see, this is the effect on the aircraft in the sky. Lastly, moving the left stick, left and right, changes yaw. So it changes the orientation of the front of the UAS throughout space. The next maneuver we're going to talk about is the normal takeoff and climb. After the normal takeoff area is clear, full application or a nice smooth application of the left stick up is given to give the aircraft increased thrust to have it climb, and then a forward stick pressure is used to move the aircraft forward. The next maneuver we're going to talk about is straight transects. In this maneuver, we will use the left stick to yaw the aircraft towards a point that we want to go to. We will then push the right stick forward and have the aircraft fly out to a certain point. In this case, this point is the tree. Upon reaching the tree, we will stop our forward movement by releasing the pressure on the right stick and then bring the aircraft back by pulling the right stick down. We'll do this until we get over our original starting point. Throughout the maneuver, we try not to use the left stick to control yaw. Next maneuver we're going to talk about is the box pattern. In this maneuver, we're going to predetermine distances that we would like to fly to. As you can see in the simulation here, we're first going to start out by flying to this predetermined distance by using the right stick and moving it forward, stopping at the point by minimizing the controls, then moving left by using the right stick and moving it left, then stopping at the next point, then moving the aircraft back by using the right stick and pulling it down, and then moving the right stick to the right to finally complete the box pattern. Sometimes additional stick movements may be required to keep the UAS in the corner positions, but this will vary based on UAS. Next move we're going to talk about is circles around the point. In this simulation, we're going to circle essentially the intersection of the two runways. The easiest way to do this is to first yaw the aircraft, pointing towards the center of the point you'd like to circle around, then adding a roll input by slowly moving the right stick to the left or right direction. As the aircraft translates across the sky, you can input the left stick in the opposite direction, either left or right, to continue to move the nose of the UAS towards the center of the circle. So as you can see in this video, we have right stick movement causing the aircraft to move to the right, and left stick movement in the opposite direction to keep the nose of the aircraft pointed towards the center of our point. The next maneuver we're going to talk about is the loss of orientation exercise. In this exercise, the student will fly the UAS towards the edge of visual line of sight, at which point the student will look away and the instructor will input certain controls to maneuver the UAS and confuse its orientation with that of what the pilot remembered its original orientation to be. From there, the pilot will have to use control inputs and their knowledge of what control inputs do in order to bring the UAS back safely to its original starting point. As you can see here, we'll pull up the binoculars to show the aircraft, and we're inputting left roll. When we do so, the aircraft ends up moving to the right. Hence, when we also add backstick, the aircraft moves away from us. And to remedy this issue, we're going to have to yaw the aircraft in an orientation so that the camera or the front of the aircraft is facing away from us, so our control inputs correctly correlate with how we'd like the aircraft to return. This is one option for returning the aircraft in the visual line of sight loss of orientation exercise. Next maneuver we're going to talk about is a normal descent and landing maneuver. In this maneuver, we're going to be starting up at altitude and slowly bringing the aircraft down. Once the aircraft is above us, we're going to try not to move much of the right stick, but we are going to move the left stick down in order to decrease the thrust and have the UAS return to a landing altitude. The next maneuver we're going to talk about is the low fuel, low battery and emergency landing maneuver. In this maneuver, we're going to try to bring the UAS back to its original starting point as quickly as possible. And this can be done by using a combination of controls. So instead of bringing the UAS back with just using the right stick and bringing it back in segments where we pull the stick back and have the aircraft return just in pitch and then in roll to maneuver the UAS over its original starting position, we could combine control inputs in order to get the aircraft on the ground as fast as possible. So this would look like bringing the aircraft back in pitch, but then also using yaw to orientate the tail of the aircraft towards the original starting point. The difference between the emergency landing maneuver and the normal landing maneuver is we aren't as concerned with safe altitudes when starting our final descent with the emergency landing, because in the emergency landing, the aircraft needs to get on the ground as fast as possible. Whereas in a normal landing, you'd like to stay high to avoid any obstacles and to complete a stabilized approach. The emergency landing should be stabilized, but altitude can vary as the aircraft moves closer and closer to the landing zone, as demonstrated in this video. Thank you very much for watching. If you have any questions, please don't hesitate to reach out at the emails provided on the website.